Hello again, everyone. Alan Shura here, November 5th, 2017. We'll carry on with the initial testing of the X1 prototype. We will show the advantages of the low resistance circuit, LRC. I have the power supply set to about the same level. I won't touch the power supply in this test. It's at 17 volts potential, and after it runs around 3.25 amp. There'll be about 20 minutes of momentum gain for the motor, angular momentum. But first, I want to talk a little bit about the testing equipment. I'll try to use these meters here, and when they first shipped I got one that was damaged, or it was calibrated incorrectly rather. It only showed a tenth of the amps. This one here worked, so I'll use it. This is brand new out of the box, but these took a little while to arrive, and the accuracy is about 1%. They'll go up to 2 kilowatts, but with these ones the voltage is too low for the last test for them to use it, because they only work 4.5 volts and above, so they're not so good for low voltage situation. Also, I in my prior use they appear to consume a considerable amount of power, while these ones consume only 0.003 of an amp between 4 and 20 volts, which is almost very little power compared to these. And this one has the time, this one doesn't. So I'll run a 1-hour test, or I'll be running some 1-hour tests with these and see how it works. And I'll try to place the power draw behind the diode, and so that way the input load will be shown in front of the coming from in front of the diode, and should I record another output load, then I've got a second one for that. But we have to go to the higher power levels, and this one here is more accurate, and it's accurate to 0.5% up to 1 kilowatt. These are 1% accuracy to 2 kilowatts. So we'll give that a try. Okay, here we are ready for our test using the circuit. It will be a 1-hour test. Unfortunately, this particular meter does not have the time. So, use this clock and set the time for half an hour. Or pardon me, I'll set it for 1 hour. It could take up to 20 minutes for the motor to reach full momentum. So when the alarm goes off, when it reaches 1 hour, we'll end the test. Start the test now. Unfortunately, we had to adjust the dials there, so we'll just see what potential we have here. Okay, we're starting like this, so we'll hold the dials to that. It didn't quite have the momentum to start there. Well, the amp doesn't agree with the power supply amp at all. And the power supply always seems to show a higher amp. But anyway, we'll have the time and we'll use just this 1 meter. There's no load. So this is only with the configuration, no load. So it does have a load, the load being the generator side of it. So it could take up to 20 minutes to reach momentum, and let's see what happens. Volts are still rising. As you can see, the momentum is increasing. It says it's using 15 watts. As I said, these meters seem to consume quite a bit of power. So it's connected behind the diode for the input power to the meter. And we're still increasing. It's not balanced very well, but so it could be better balanced. So there's some losses and friction there too. Starting to warm up a little bit. Voltage is still rising. Okay, well, we'll see what happens. We'll come back to this test towards the end, near an hour. The clock has just gone off. It's been 1 hour. So we'll take a look at our reading. 16 watt hours. The voltage has risen, the amperage dropped slightly with the momentum. And it's more or less stabilized around here, around this point. There's the final reading. I don't know why the amperage is so much higher on this power supply, but we're taking the power from the diode there. So that's the final reading. Okay, let's set the clock again for the test where we're not using the LRC circuit. So this would be the ordinary way of pushing this generator load and the motor generator. So we reset this. That was the ending potential. And we'll reset the clock for 1 hour. Again. Okay, so I guess we'll have to end 1 minute after. This is you know what? It wouldn't even turn. That's the same power going in. So I have to crank up the amp a bit. Okay, we're going now. Did I get this right? You know, it's not even registering there because, as I say, this meter doesn't run unless its voltage is up there. Okay, well I cranked the amps up, so we'll have to wait for this thing to wake up. When it goes over, get some momentum, and maybe it'll pass over that 4.5 volts minimum before this meter starts really working. As I say, it takes a lot of power out. That's probably why the amperage is part of the reason why the amperage is higher there. So let's see what happens. Let's see if this meter goes on. We know that it's not going to record as much power, but we'll try and keep it running for an hour if it can get to the 4.5 volts. Okay, we're nearing the end of the test hour, and this is the ordinary connection, not using the circuit, the LRC circuit. I had to crank up the amps even to get it going, and at the end of the hour, this is the reading on the power supply. Unfortunately, although you can just barely start to begin seeing some numbers in this meter, we could not get into the operating range of the meter. So I had to crank up the power, so we'll see what the ending potential is. But here's how it's running. So we weren't able to record our data using that meter because it uses a heck of a lot of power, in my opinion. But we'll have another test using this meter, which is very, very accurate and uses very, very little power at all. Yeah, I just took off the circuit, and then this started glowing again because the meter uses so much power, and hard to get in that accuracy at these levels. That was the ending potential, so I increased the potential just to overcome the momentum to start it moving with the usual usage without the LRC circuit. Check out the Indiegogo campaign, contribute if you can, what you can, and spread the word on social media.